Hello dear students, welcome back to physics online session. So in last couple of days, we're discussing about a capacitance. So in case of capacitance, we come to know the formula for capacitance of parallel plate capacitors without dielectrics, with the dielectrics, and as well as if these capacitors are arranged in a series combination, what about its capacitance value, and if these capacitance are connected in a parallel combination, what will be its effective capacitance value. Already we come to know that. So now today in this class, let me focus on some numerical aspect related to these capacitance. So let me remember that formulas here. Capacitance of parallel plate capacitor without dielectrics or Aries act as a dielectric. So that is C naught is equal to epsilon naught into A divided by D. So without dielectrics or Aries act as a dielectric here. So in presence of dielectrics, K into C naught here. C is equal to K into C naught, where K is dielectric constant, its value is C divided by C naught here, or C is equal to K into epsilon naught into A divided by D here. Why? Because C naught value is this much. So now, in case of that capacitance, if that entire space is filled with the dielectric, this is the formula. If the dielectric material is partially filled, means C is equal to epsilon naught into A d minus of t 1 minus of 1 by k. So this is the formula here. So instead of the dielectric medium, if that metal slab is introduced, that metal slab having certain kind of thickness, this is the formula I need to use here. So these are all the formulas related to capacitance of parallel plate capacitor. So now let me consider that in case of that series combination and in case of that parallel combination. So if the capacitors are arranged in a series combination, 1 by C of S is equal to 1 by C1 plus 1 by C2 plus 1 by C3, like that. Or if the two capacitors are connected in series combination, C1 into C2 divided by C1 plus of C2. So this is the connecting formula. In case of that series combination, which quantity will be remain same? The charge is remains same. So total potential difference is equal to sum of the individual I said. So now I have the formula for to determine the branch potential difference. So in order to determine the branch potential difference, what is the connecting formula? Total potential difference into capacitance of other branch divided by total capacitance or potential difference across first capacitor. So V into C2 divided by C1 plus of C2. So our V2 is equal to V into C1 divided by C1 plus of C2 here. So in case of that parallel combination, so C of P is equal to C1 plus of C2. In case of series combination, effective capacitance is less than individual. In parallel combination, effective capacitance is greater than the individual. So C of P is equal to C1 plus of C2. In case of parallel combination, which of the quantity will be remain same? So potential difference is remain same. So total charge is equal to sum of its individual I said. So in order to consider that branch charge here, branch charge or individual charge you may call. So branch charge is equal to what? Total charge into capacitance of the same branch, capacitance of same branch divided by total capacitance. So this is the generalized formula here. Or for example, charge on the first capacitor Q1 is equal to total charge into capacitance of the same branch divided by total capacitance, or Q2 is equal to, I will write that total charge into capacitance of same branch divided by total capacitance. So these are all the connecting formula. So now we would like to solve some numericals on these capacitance here. So let me focus on such numerical here. connected bodies having a respective capacitance. So two connected bodies are there. So these capacitance, so respective capacitance C1 and C2 are charged with total charge q. So what is the total charge here? Total charge is q amount. The potential of the two body is, so look at here, two connected bodies having a capacitance C1 and C2, then total charge is q amount here. Then so what is the potential difference of the two body here? So what is the connecting formula here? So charge q is equal to what is the generalized formula for capacitance? C is equal to q by v, or q is equal to what? C into v. So look at here, C is equal to q by v here. So I will take that q here, q is equal to C into v here, q is equal to. So connected bodies having a respective capacitance C1 and C2. So that is C1 plus of C2, and potential is same. So that is, so into V I can call, or V1 is equal to V2 is equal to V in generally. Or if I take this one as a V1 here. So if I take this one as a V1 means what is the formula here? Q divided by C1 plus of C2. If I take this as a V2 here, so then what will be the formula? So Q divided by C1 plus of C2. So this is the formula. So in that option, so Q divided by C1 plus of C2. So again that Q divided by C1 plus of C2 here. So we'll look at next one. Three connected condensers A, B and C having a total charge of 48 microcoulomb. So three connected bodies are there. So it is having a total charge. So Q is equal to 48 microcoulomb, 10 to the power of minus 6 total charge. Ratio of their capacitance are 1:3:2. The charge on them individually. So which thing I need to determine here? Individual charges. So in order to consider that individual charge, so I said that, or branch charge. So in order to calculate that branch charge, so what is the connecting formula are having? So ratio of their capacitance they mention as a 1:3:2 here. So C1 is equal to 1 microfarad. So 1 into 10 to the power of minus 6. C2 is what? That 1:3. So 1:3:2. So 10 to the power of minus 6 farad. And C3 is 2 into 10 to the power of minus 6 farad here. So individual charge or branch charge. Q1 is equal to Q into C1 divided by C1 plus C2 plus C3 here. So look at here. Q is how much? 48 into 10 to the power of minus 6. What's that C1 value here? 1 into 10 to the power of minus 6 divided by C1 plus C2 plus C3. 1 plus 3 plus 2 into 10 to the power of minus 6. Q1 is equal to 48 into 10 to the power of minus 12. So this is 6 into 10 to the power of minus 6. So 8 into 10 to the power of minus 12 plus 6. So that is 10 to the power of minus 6 coulomb. What is that Q1 value here? Q1 is equal to 8 microcoulomb. So what about Q2 here? Similarly, Q2 is equal to what? Q into C2. So Q into C2 divided by C1 plus C2 plus C3. Q value is 48 into 10 to the power of minus 6. C2 value is how much? So 3 into 10 to the power of minus 6 divided by C1 plus C2 plus C3. So that is 6 into 10 to the power of minus 6 here. So Q2 value is 24 into 10 to the power of minus 6, or 24 microcoulomb. So Q2 value. Hope you are understanding here. Similarly, Q3 value I need to find out. What is the formula? Q into C3 divided by C1 plus C2 plus C3. Q value is how much? 48 into 10 to the power of minus 6. So C3 value is 2 into 10 to the power of minus 6. So total capacitance 6 into 10 to the power of minus 6 here. So 16 into 10 to the power of minus 6 coulomb, or 16 microcoulomb. Which option is right here? So Q1 is 8, Q2 is 24, Q3 is 16 here. 8, 24, 16. So Q1 value and this is Q2 value and this is Q3 value here. So hope you are understanding here. They asked to determine that branch charge here or individual charge. So in order to get that individual for generalized formula, so total charge into capacitance of same branch divided by that next one. The capacity of parallel plate capacitor, each plate area of 10 centimeter into 10 centimeter length into breadth are separated by a distance of 1 millimeter is. So capacitance value I need to find out here. Area value they mention. So 10 centimeter into 10 centimeter. So that is 100 centimeters square. So area. So 100 means 10 to the power of 2. So centimeter square means 10 to the power of minus 4 here. So value is 10 to the power of minus 2 meter here. What's the answer here? 10 to the power of minus 2 here. So distance value is 1 millimeter. So that is what? 1 into 10 to the power of minus 3 meter. What is the connecting formula for capacitance of parallel plate capacitor? Epsilon naught into A divided by D here. So where epsilon naught value, permittivity of free space, in that first chapter I got that value 8.82 into 10 to the power of minus 12, where area value is 10 to the power of minus 2. So distance is 10 to the power of minus 3 here. So C naught, shall I take this one as 8.82 into 10 to the power of minus 14 plus of 3 here. C naught is equal to 8.8 into 10 to the power of minus 11 farad, or shall I take that 88 into 10 to the power of minus 12 here. 10 to the power of minus 12 means what? Pico here. 88 picofarad. What is the answer here? Capacitance of parallel plate capacitor is 88 picofarad here. Okay, we'll move next one. A body is charged to a certain potential here when additional charge of 60 nanocoulomb is imparted to it. So 60 nanocoulomb of charge I am providing here. Q value is how much? 60 nanocoulomb. Nano means 10 to the power of minus 9 here. The potential is to be found about 15 millivolt here. So V is how much? 15. Milli means 10 to the power of minus 3 volt here. Find the capacitance of the body. So generalized formula, C is equal to Q by V. That's it. So Q is how much? 60 here. 60 into 10 to the power of minus 9. 15 into 10 to the power of minus 3. So that is C is equal to what? 4 into 10 to the power of minus 9 plus 3. So that is 4 into 10 to the power of minus 6 farad, or 4 microfarad. What is the answer here? 4 microfarad here. So we'll look at next one. So in case of that capacitance, okay, between the plate of a parallel plate capacitor of capacity C. So two plates are there. So between these two plates, its capacitance value is C here. So for example, this is one plate and this is another plate. Between these two plates, its capacitance value is C here. Two parallel plates of same material and area same as the plate of the original capacitor are placed. So initial plate is A and B. Between these two plates, capacitance will be C. So now I will consider that two more plates. These two plates are placed parallel here. So these two plates are placed parallel here. C and D are the plates, and these two plates are placed parallel here. So placed parallel. If the thickness of these plates is equal to 1/5 of the distance between the plate of the original capacitor. Original distance, so look at here, original distance is D here. Thickness of these two introduced plate will be, so shall I take this thickness is D by 5 here. This thickness is also D by 5 here. So look at here, thickness is D by 5 here. The new capacitance value will be, so initial capacitance value C is equal to epsilon naught A divided by D here. Now C dash is equal to what? Epsilon naught into A, same area they mentioned, divided by D dash value here. So d dash value is how much here after introducing the plate C and D here. So look at here, initial distance is D here, so d dash is equal to D minus of, so this is D by 5, this is D by 5, so D by 5 plus D by 5, 2D by 5. Did you get my point? So distance value, so new distance value will be, so 5D minus of 2D divided by 5, 3D by 5 here. So new distance value is 3D by 5. Let me fill here. So C dash is equal to epsilon naught into A divided by D dash means what? 3D by 5 here, or C dash is equal to 5 by 3 epsilon naught into A divided by D here, where C dash is equal to 5 by 3. So epsilon naught into A divided by D, shall I take it as a C here? So C dash is equal to what? C dash is equal to 5 by 3 into C. So hope you are understanding here. So we'll move next one. The plate of parallel plate capacitor are charged up to a 200 volt. So parallel plate is getting charged by providing a voltage of 200 volt here. A dielectric slab of thickness 4 millimeter is inserted between the plate. So between the plate I will introduce a dielectric slab. Its thickness is 4 millimeter, or 4 into 10 to the power of minus 3 meter. Let me take that. Inserted between the plate. Then to maintain the same potential difference between the plate of the capacitor, distance between the plate is increased by 3.2 millimeter here. So look at here. So here the two plates are there. Two plates are placed parallel to each other. So if I place the dielectric medium, so its dielectric medium having the thickness is 4 millimeter here. After introducing the dielectric medium value, what happens here? Capacitance value will get increase here. So by this formula, C is equal to K into C naught here. So capacitance value is directly proportional to dielectric constant. If you place the dielectric medium means its capacitance value will get increase now. But they mention that to maintain the same potential difference between the plate of the capacitor, distance between the plate is increased by 3.2 millimeter. So in order to maintain the same potential value, so capacitance value is increases means so voltage value will get decrease here, but I want to maintain the same 200 volt here. So in order to maintain the same voltage, I need to increase the distance. Why? Because so look at here, so all are interconnected. C is inversely proportional to D here. As the distance is increased, capacitance value will get decrease here. So what happens here? Capacitance value will get decrease here. So it will give the same potential value here. So next one. So in order to maintain the same voltage, so they mention that distance between the plate is increased by 3.2 millimeter here. So distance between the plate is increased by 3.2 millimeter. So X value is 3.2 millimeters, so 10 to the power of minus 3 meters. So initial distance is D, it is increased by 3.2 millimeter here. The dielectric constant of the slab is K value. What is the connecting formula I said? In case of that capacitance of a parallel plate capacitor, when the dielectric constant is partially filled, so in order to get the same original capacitance value, so what I said, I need to maintain the distance between the plate. So that distance X is equal to what? So X is equal to T into 1 minus of 1 by K. So hope you are remembering this formula. So X is equal to what? X is equal to T into 1 minus of 1 by K here. X is how much here? So distance they are going to be increased by 3.2 millimeter here, 10 to the power of minus 3, and thickness is how much here? So 4 into 10 to the power of minus 3, 1 minus of 1 by K. So 3.2 divided by 4 here, 1 minus of 1 by K, 1 by K here. So that is 8, means 3.2 means 0.8 here. So 0.8 is equal to 1 minus of 1 by K here. So just I will minus 1 by K if it goes to that left side, 1 minus of 0.8. So 1 by K is equal to what? 0.2 here. 1 by K value is how much? 0.2. K is equal to 1 by 0.2, or I will write that 10 by 2 here. So K value is how much here? So K value is 5 here. What's that K value? So look at here, in case of capacitance of a parallel plate capacitor, when dielectric medium is partially filled, so I said that capacitance value will get increase here. So generalized formula given, epsilon naught A divided by D minus T 1 minus of 1 by K here. Okay. So in order to get that same initial capacitance value, so what suppose I have to do in order to get that? So without dielectric medium, so for example its capacitance is C naught. After placing the dielectric medium, its capacitance value is C. So in order to get that same capacitance value as a C naught after placing the dielectric medium also. So did you get my point here? After placing the dielectric medium also, if I get that same initial capacitance value, means what suppose I have to do? I have to vary the distance between the plate here. The capacity of parallel plate capacitor formed by parallel plate of same area A here is 0.02 microfarad. Capacitance of a parallel plate capacitor formed by plate of same area is 0.02 microfarad here. So C naught value 0.02 micro means 10 to the power of minus 6 farad, or C is equal to 2 into 10 to the power of minus 8 farad here. With air is act as a dielectric. Now one of the plate is replaced by the plate of area 2A here. Initial area is how much? A1 is equal to A here. So they mention, so look at that question carefully. Out of two plate here, if one of the plate is replaced, they mention one of the plate is replaced, its area is 2 times of A. If only one plate area is getting changed, means whether capacitance value will get changes or not, I need to understand. So look at here. Here two plates are there, A and B. Its area is A and its area is also A. Then the capacitance value is this much. In that next case, they mention one of the plate area I will make it as a 2A here. Another plate area will be A only. Only one plate area I made it as a double. So if only one plate area is double, means for example here number of positive ions are there, here number of negative ions are there. So whether that capacitance value will get changes if you increase only one plate here? No. Why? Because number of negative ions and number of positive ions. So this won't get part here. So if you increase only one area plate, means it doesn't affect to its capacitance. If you increase both the area, means then only capacitance value will get changes. Why? Because epsilon naught A divided by D here. C is directly proportional to A here. But in that question they mention only one plate area they increased, means so it won't affect to its capacitance. So capacitance value will be same here. So then okay, look at here. In that question they mention now one plate is replaced by the plate of area 2A with a dielectric K is equal to 2 here. So dielectric constant value is 2 here. Dielectric constant value is 2. Then capacitance, new capacitance value. So C is equal to what? So C is equal to K into C naught here. C is equal to, so K value is how much? 2. So C naught value is how much? So 2 into 10 to the power of minus 8 here. 4 into 10 to the power of minus 8 farad, or C is equal to 0.04 microfarad here. 0.04 microfarad. So hope you are understanding here. Here they mention that A2 value as a double, but listen carefully. In that question they mention only one of the plate area is increased, they mention. If two plate area will get double, means then only capacitance value will get changes. If only one plate if you change, means it doesn't affect to its capacitance value. Okay. Next one. The radius of circular plate of parallel plate capacitor is R. So look at here. The radius of circular parallel plate capacitor is R here. Air is there as dielectric. So listen here, I will read out the question once again. The radius of circular plate of parallel plate condenser is R here. One circular plate is there. That circular plate having the radius R here. air is act as a dielectric, the distance between the plate if its capacitance is equal to that of isolated sphere of radius r dash is. So which thing I need to determine here? So look at here, the distance between the plate if its capacitance is equal to, so capacitance is equal to that of isolated sphere of radius r dash is. So look at here, so one circular plate is there, so like that. So in case of capacitance of a circular plates, its radius value they mention as a r here. So what's that radius value here? Radius value they mention as a r here. So in this case c is equal to epsilon naught into a divided by d here. So where area I will take it as a pi into r square divided by d. So did you get my point? Capacitance of a parallel plate capacitor, but if it is in a circular form, so I will take that epsilon naught into pi into r square. Area means pi r square, area of the circle here. So capacitance of isolated sphere, what is the connecting formula? Capacitance in case of that isolated sphere here. So did you remember that c is equal to 4 pi epsilon naught into r here? So instead of c, shall I write it as a 4 pi epsilon naught into r here? So epsilon naught pi into r square divided by d here. So distance value, so pi will get cancelled, epsilon naught term will get cancelled here, 4r divided by. So look at here, so they mention that distance is r here, so radius is r dash they mention. So 4r dash is equal to r square divided by d here. So distance is equal to r square divided by 4r dash here. What's the answer here? Distance between the plate here, d is equal to r square divided by 4r here. So distance d is equal to r square divided by 4r dash here. So sphere having the radius r dash they mention. So that's what I took, that d is equal to r square divided by 4r dash here. So we'll move next one. Okay. The capacitance of three capacitor are in ratio 1:2:3. So capacitor are in the ratio C1 is to C2 to C3, 1:2:3 here. Okay. The equivalent capacity when connected in parallel is, so equivalent capacity when it is connected in parallel is 60 by 11 microfarad. So in that capacitance in parallel, their equivalent capacitance when they connected in parallel is 60 by 11 microfarad, more than that when they are connected in series here. So look at here, so in case of series combination 60 by 11 microfarad, more than that in case of series. So if you connect these capacitors in parallel combination, you will get that 60 by 11 microfarad. If you connect these capacitors in a series combination, you will get less than that of 60 by 11 microfarad. It means that 60 by 11 microfarad, more than that when they are connected in series. So look at here, in case of series combination, effective capacitance is less here. The individual capacitors of capacitance in microfarad is, so which thing I need to determine here? Individual capacitance. So look at here, they mention that their equivalent capacitance when connected in parallel is 60 by 11 microfarad, more than that when they are connected in series combination. In the sense, I will take that Cp minus of C of S value here. Cp minus of C of S value is 60 by 11 microfarad. Why? Because they mention that equivalent capacity when connected in parallel is 60 by 11 microfarad, more than that when they are connected in series. So Cp minus of Cv is equal, C of S is equal to 60 by 11 microfarad here. Now let me find out that individual capacitance here. So capacitance value they given in terms of ratio here. So if they given in terms of ratio means C1 is 2 times of C here. Sorry, C1 is C here. C2 is 2 times of C. C3 is 3 times of C. So I will find out that C value first. Is it right? So in case of parallel combination, C of P is equal to what? C1 plus of C2 plus of C3 here. So look at here. C1 is what? C plus of 2C plus of 3C. C of P is equal to, shall I take that 6C here? So C of P is equal to what? 6C here. For example, let me take this as a equation 1 and this will be equation 2 here. And in parallel combination, 1 by C of S, it is equal to what? 1 by C1 plus 1 by C2 plus 1 by C3 here. So 1 by C of S is equal to 1 by C, 1 by 2 times of C, 1 by 3 times of C here. Let me take that LCM here. 6C here. So shall I take that 6 here? 3 here, 2 here. Okay. 1 by C of S is equal to 11 by 6C here, or C of S is equal to 6C divided by 11 here. I will take this as a equation 3. Now let me fill that 2 and 3 value in equation 1 here. So I will fill that, I will fill that equation 2 and 3 value in equation 1. So put equation 2 and 3 value in equation 1. Then we will get C of P. So what's that answer here? 6C minus of C of S. So C of S, what's the answer here? 6C divided by 11. So it is equal to what? 60 by 11 here. 60 by 11 here. 11 into 6. 66C minus of 6C divided by 11. It is equal to 60 by 11 here. It will get cancelled out here. 60C is equal to 60. So C is equal to 1 microfarad. So finally I got that C value here. So C value is 1 microfarad, means C1 value is how much? C1 value is, so C means 1 microfarad. C2 value is how much? So 2 times of C. 2 into 1 microfarad. So 10 to the power of minus 6. So 2 microfarad. C3 is how much? 3 times of 3 times of C here. C value is 1 microfarad. So that is 3 microfarad. What is that individual capacitance value here? 1 microfarad, 2 microfarad and 3 microfarad here. So hope you are understanding these things. The remaining thing will continue next class.